right, let's look at another example where we have a little bit of a shift. So in this case, we're going to do the exact same thing as we did with the first problem. We're going to look at the denominator and determine what would make the denominator, what value for x would make the denominator 0. So basically, we're going to look at x plus 1, and we can actually write down what value for x plus 1 equals 0. So you can probably do this mentally and see that if we subtract 1 on both sides, that x would equal to -1. So -1 would make this function undefined. So that means we have a vertical asymptote at the line x equals -1. So the denominator will tell you your vertical asymptote. I'm going to go ahead and already sketch -1, the line on the graph. So here is the line x equals -1. I'm going to put a dashed line, and it is going forever, so I'm just going to put arrows. All right, now take a look at this equation. If this whole fraction right here, if you take a look at it, because we have the numerator 3, then if I input any other value for x, this fraction that I circled will never equal 0. So if this fraction never equals 0, that means y can never equal -2. So our horizontal asymptote is actually y equals to -2. So let's go ahead and sketch the y equals -2 on the graph. So this is the equation of y equals -2. Now you can look at this as where your graph is going to approach. It's going to be a curve going towards these two asymptotes. So if you want to be a little more accurate, you can actually see what happens left of -1 and what happens right of -1, because that is my vertical asymptote. So if we look at right of -1, we have the value 0, and we can also plug in 1. So we're just going to plug in 0 into this fraction. So 0 plus 1 is just 1, and 3 over 1 is 3, and 3 minus 2 is 1. Y is 1. So we can go ahead and put that point. When x is 0, y is 1. So that is actually a y-intercept. All right, what happens when, let's plug in the value 2. So I can choose any points to pick. I'm just going to pick 2 because then we don't end up with a fraction. Not that fractions are bad, but if I plug in 2 for x here, then 2 plus 1 is 3, and 3 divided by 3 is 1, and 1 minus 2 is -1. So I'm going to go ahead and put the point when x is 2, y is -1, which is this value right here. And we already know this is a hyperbola, so if we sketch the right side, it's going to be a curve going towards the asymptotes, going through these 2 points, and then continuing towards the horizontal asymptote, but never reaching it. So now we have our right side. Let's go ahead and look at left of -1. Well, left of -1, we have -2. And remember, we could choose any value left of -1 just to make the sketch a little bit more accurate, even though they did say it is a sketch. I could just sketch 2 curves going towards the asymptotes, but if you want to be a little more accurate, plug in points. So let's go ahead and see left of -1, we said -2, and then another value I could put in is -4. So -2 plus 1 is -1. I would have 3 over -1, which is -3, and -3 minus 2 is -5. So that is the point -2, -5 right here. All right, if we plug in -4 for x, -4 plus 1 is -3. 3 divided by -3 is -1, and -1 minus 2 is 3. So to input the point at -4, it is -3. And you could see when you draw your curve that it will go through these 2 points and then towards the asymptotes. So I'm just going to go ahead, draw it to the best of my ability. So there is a sketch of the graph. Now, we have the vertical and horizontal asymptote already. Now to talk about domain. Well, the domain is all the x values, all possible x values, but we already said that x equals -1 will create an undefined situation. So we could say that the domain is all real numbers except x cannot equal 2. So I'm going to write down here -1. Now, notice how the vertical asymptote is related to the domain. So the vertical asymptote, again, is x equals -1. Therefore, the domain is x cannot equal -1. Now, let's take a look at the range. What do you think the range will be? If you said all real numbers except y cannot equal -2, then you are correct. So this pretty much finishes this example. This is all you needed to do. And in class, I could show you another way we can write the domain and range.